Hey Panthers, it's Mrs. Sherburne. I'm in my kitchen, and instead of doing some cooking, we're going to do some more chemistry. This is part 2 of a 5-part video series, and if you didn't watch part 1, you're going to want to check that one out on the decomposition reaction. So if you remember, there are 5 different types of reactions, and I'm going to kind of showcase a demonstration or an activity that we would have done in the lab for each of the 5 types. Video 1 was with decomposition. So there's going to be 3 goals as I showcase this demonstration. And the first goal or target is to be able to balance the chemical equation that goes with the reaction we see. Identify which, kind of narrowed it down, which of the 4 now types is the reaction, and be able to draw a picture. Okay, so for the reaction that we're going to do today, my safety glasses, I put, oh yeah, there I'm at. Come a little closer and take a look at this piece of magnesium ribbon or tape. This is pure magnesium ribbon. You'll find this if you've ever known anybody that's been a welder. So there's a lot of magnesium in the welding strips that welders use. So really, I'm going to try and burn this strip of magnesium ribbon, okay? Okay, the safety precaution with this reaction is that I can't stare directly at the flame as it touches the magnesium ribbon. So I'm gonna watch until I get it close to the flame, get it started on fire, and then I'm gonna kind of turn my head. And the reason for that is, I'll tell you the reason afterwards. All right, here we go. All right, you should have noticed a really bright white light that was given off. And I want you to zoom in a little bit closer on kind of what my product looks like, because it's almost ashy. And if I had stared at that flame, just like with welding, they have to wear the mask because it can really hurt or even burn the back of the retina of your eye. So that's why you wouldn't want to stare at the flame. All right, let's talk about the chemistry that's happening. So with this one, it can be a little tough to figure out what are my reactants. Because I know you think, well, it was just magnesium ribbon, that was the only reactant. But we burned it. And when you burn something, you have to have oxygen. So sure enough, oxygen is one of my reactants. These two chemically combine in order to make those white ashes at the end. So I have words up here. Magnesium metal reacts with oxygen gas. Remember, oxygen's diatomic, it comes in pairs, to make magnesium oxide. And I know some of you are asking, well, how did you know that that was the formula for magnesium oxide? If you remember, we talked about how many outside electrons magnesium has. If you look at your periodic table or on your Chem info sheet, you'll remember that it has 2. What would make it happy? It would be to lose those 2 electrons. So if it loses 2 electrons, what charge does it become? It becomes 2+. Oxygen becomes 2 negative because it needs 2 more electrons. And if magnesium has 2 to give up and oxygen wants to gain 2, then you only need 1 of each. Okay, so that's where my formula comes from. But our goal is to balance this equation. So as I'm looking at it, what's in front of my ruler for my reactants and what's after, my magnesium's good. I've got 1 of each. My oxygen is not. I've got 2 on this side, and it looks like I need another 1 over here. So if I draw another MgO, Now my oxygens are good. And I know you're saying to yourself, well, Mrs. Sherburne, the oxygens are good, but magnesium's not now. You're absolutely right. So if I have 2 magnesiums on the right-hand side for my products, then I'm going to need 2 magnesiums over here. And I'm not going to draw them connected. I'm going to draw 2 separate molecules, because this is not diatomic. Okay, so now we're just going to write our coefficients in front, those numbers. How many magnesiums do I have? I have 2. How many molecules of oxygen? There's only 1. You can write a 1 if you want, but you don't need to. And how many particles or molecules, formula units technically, of magnesium oxide are there? There's 2. So it's balanced. So we've got 2 of our 3 goals done. We've got it balanced. We drew a picture. Now we just need to identify what type this is. So if you look at this, I've got 2 things that are chemically reacting together. And how many products did I make? I only made 1. Here are our choices: single replacement, double replacement, combustion, and combination. The reaction type, the name, kind of gives it away. We took 2 things and we combined them to make 1 product. So it is a combination reaction. All right, Panthers, thanks for watching. Stay tuned for video 3, where we'll focus on a different reaction type.